Now we're going to look at integrating tangent of theta, d theta, and this maybe on the surface seems a little bit well, unfamiliar perhaps, maybe, so most of us have memorized like the integral of sine and the integral of cosine, but perhaps we have not really encountered the integral of tangent much. But in fact, this is very, very simple to derive, and it'll take just a matter of a few seconds. And so this will probably be a very short video after all. The way to do it is to write tangent using the definition of tangent. That is to say, the integral of tangent we can write as the ratio of sine to cosine d theta. Okay, and then you'll notice that this is very good in the sense that I have here, let me write it this way, I have on the top sine of theta d theta, and on the bottom I have cos of theta, and this on the numerator is truly, it's the derivative of what's on the denominator. So the reason why I say that's so good is because now by just letting u be the denominator, cos of theta, when I differentiate that, I get minus sine of theta d theta. Of course, the only difference is that minus, but we can deal with that because I can multiply through by the minus. So if I multiply both sides of this by minus 1, I get a minus du is equal to a sine of theta d theta. Okay, and so you'll see that right away this is what's sitting on the top, the numerator, and so I'm ready to plug in and finish the problem, because this is then going to reduce to the integral of minus du, which is the numerator, this term right here. Okay, and on the bottom we called cos theta just u, and so this is a very simple integral to evaluate. This is nothing other than minus natural log of u, and then we get a constant of integration. And so to finish, we have to put back what u is, and so therefore the integral that we were after, the integral of tangent of theta d theta, is equal to minus the natural log of the absolute value of u. In this case, u is cos theta plus the constant of integration. Okay, so as promised, that was real short and sweet and very simple to do, and this is one of those things that I probably wouldn't urge you to memorize, because the derivation is so very simple to do. Once you write out by definition what tangent is, and then just notice that what's sitting up on the top is really the derivative of what's on the bottom. So with a simple u-substitution of the denominator, with the only exception being that sign, as we mentioned, everything else falls into place very simply. Okay, now the next video we're going to do an example of a circle and try to find the area of the portion of a circle sitting above a chord. So come and visit me on that next video. Thank you.